Okay, so we started first session, introduction. We didn't finish yet. So we started talking about data, right? And why data is important. Anyone can remember maybe a few things? Data can improve people's life, right? Imagine, let's say you have a clinic and you have patients coming to your clinic. Maybe you have helpline and you would like to see how people are satisfied about your service. So you can collect, you can gather data, you can make informed decision. So avoid acting on assumption. So instead of having assumption, then you have evidence in this case. Spot problem early. So if you check your data and you find some anomalies, you can know that there's a problem. Track what you work. Maybe you run a program, for example, to your staff inside the clinic, and then you can see whether the program was efficient by seeing whether the performance has increased. Okay, so find root causes, staff turnover. So you need to find out, was it incident or maybe due to some other factors have taken place? Strengthen advocacy. So instead of asking for fund, like for example, you want new phone. So instead of going and tell your parents, I need a new phone, maybe you tell the new phone has something good for you, for your lectures, for example, correct? So maybe you support with data, maybe you, when you use gadgets that can help you to improve your performance, build trust with the stakeholders. So show your losses, wins through numbers so people can trust you. Be strategic if you have limited resources, so you can plan what should be done by prioritizing which task or how resources can be consumed or implemented in order to run or in order to implement your main activities. Okay, recognize success, set goals, show your impact, and so on. And we talked about data intelligence. So data intelligence, it's about taking decision. So you have data, you gather your data, you analyze, understand, and then grow your business. Okay. So you look into market trend analysis. Maybe customers are interested in certain product through their searches or maybe question. So you know that there's opportunity maybe for you. So you need to grab this opportunity. Okay, then we talked about the key components of data intelligence. We talked about big data, data mining, event processing. Okay, event processing about predicting issues. Maybe some based on your data mining, you know that maybe some issues may happen. Then you can take, or maybe not necessarily issues, but opportunities. Like maybe your customer are requesting for certain specification in your products. So you know that if you don't take an action right now, maybe future you will lose some opportunity. So you have to consider doing something now. Online analytics, monitoring traffic, marketing, customer behavior. So you need to keep an eye on the changes. Then from data to decision. So eventually you are looking to have informed decision. Okay, based maybe on analysis you've done on the market demand, or maybe changing service based on customer feedback. You are running certain services for your business, and then you are interested to modify your service, but based on customer feedback. And we discussed about data warehouse, and simply we said it's a central repository for all your data. So you can think about data warehouse is like a big database. One big database that can hold all the data coming from different resources. Maybe you have Excel files, you have other small databases. So you gather all the data into one repository. So you can think of it as a data warehouse. Anyway, we're going to have a session talking about data warehouse per se. Okay. So the point is always you need to look into your data for what? to get information and eventually take decision. Right? Eventually take decision. And then we discussed about the types of data, structured data and unstructured data. So what is unstructured data? Come on, there's no judgment. If you answer right or wrong, doesn't matter. But during assessment, yes, make sure you answer correctly. So what is unstructured data? How you can differentiate between structured and unstructured data? Come on, guys, we said here, no silence. We need to talk. Yeah, so what is the difference between structured and unstructured? How you can differentiate between them? You say, oh, I have structured data for my task. Let's say you are doing FYP, or you have unstructured data. How would you tell? I feel like you are about to say. Yeah, so if I have organized data, how can I tell whether it's organized? If I'm looking for, let's say, age of people, I know exactly where to look. I have a specific column where I can just go to that table, that column, I can read all the ages. But if it's unstructured, that means like post. Let's say you wrote your information, your bio data into a post. Then I have to search. The data is not in a specific location, it's not organized. It's just written inside a text, okay? And then we talked about quantitative and qualitative data. So if your data is numeric by nature, yeah, try to remember this, numeric by nature, then it's quantitative. If it's text or other types of numeric, then we call it qualitative data, especially if it's text, we're talking about qualitative data. And quantitative can be discrete, can be continuous. We discussed about this. Qualitative can be nominal and ordinal. So if you have ranking nature for your data, for your text, then it's ordinal. Otherwise, it's nominal. And then we stopped last time at big data. So we already discussed big data is the need to save massive amount of data into somewhere and then being able to run some analysis. Because eventually we need to analyze the data to understand or find insights or patterns inside our data. So data can be text, can be records, habits, travel habits, and so on. Okay, and data can, because it's big now, the three core ideas behind big data that everything people do leaves a trace. So when you go watch YouTube, so YouTube will know what kind of ads is proper for you. So always you would leave trace. Data comes from different places, even from cookies on your browser, from log files on the server, from gadgets, from IoT devices, and data is complex. In this case, can be in form of text, can be voice. You know that even your phone is listening to you on Google service. So this is why later, if you are discussing with your friend about something and then suddenly you see an ad related to what you are talking about, yeah, so they have these kind of things. Big data requires innovative tools. So traditional tools that we usually do is not enough. We need something to be more efficient and able, as I said earlier, to save massive amount of data and still able to analyze it. It's not about just only saving it, but still be able to run analysis and analyze it to gain insights. And data have the big 5 V's. Sorry, this is the application on my side. So not yet. Oh, okay. Okay, so what are the 5 V's for big data? Okay, so you have volume. As we said, data is massive. So we need to think about storing data. Variety, data is in various formats. Can be in text, can be voice, can be images, can be structured data. Velocity, the data is actually running fast. You receive a lot of data all the time. Veracity is about talking how the data is accurate, because while you are storing the data and analyzing the data, you need to ensure that the data is accurate, integrate. Otherwise, there's no point of having data, right? Let's say you have a database. If we go to the normal concept and your data is not integrate, is not correct. So what's the point of having database, right? There's no point. And then the value is about analyzing the data and finding insights out of the data. So these are the 5 V's: volume, about massive size; variety, about the different format of the data; velocity, that talking about the speed, because data is coming from everywhere. So you need to be able to store this data efficiently. Veracity is about accuracy of the data, and the data is integrate, correct. And value, by gaining insight and run analysis into the data. Okay, so volume, massive amount of data, so require powerful tools to store and manage this data from billion of devices. Variety, different format, can be structured, unstructured. Velocity, about speed of data, creation and movement in real time. And then you have the veracity, about the accuracy and trustworthiness of the data. Inaccurate data is meaningless because eventually it's going to mislead you. And the value, useful for insight and benefits drawn out of the data. Now, what are the types of data analytics? When we talk about data analytics, what are the different types of analytics that you may apply? There are 4 types of analytics. You have descriptive, diagnostic, predictive, and prescriptive. Okay? So in short, what is descriptive? It's what's happening. You're talking about the past or maybe now. Let's say you collected data and then you are interested to see general description about the data. So maybe you calculate mean. Let's say, like here, I got structured data for you in a database. Then I can see the average for age, the standard deviation. Okay, so all of these are called descriptive data, describing what's happening. So I have students, maybe how many, 20, for example, or 30. Then the average age, let's say, is 21. Median, maybe 22, for example. So all of this called descriptive, just looking what's going on, what's happening right now. And then diagnostic, why is it happening? So you're talking about looking into why. Okay, so the first one, looking into what? Just describe. What do you have? Okay, what's happening? While diagnostic, into you are looking into why. Why is it happening? Okay, maybe you have a problem. Okay, then you are trying to inspect out of your data to find out the root cause. So maybe you run root cause analysis. Then you go into predictive, and prescriptive is about future. So predictive is, are you able, based on this data that you have at hand, to predict future? Let's say I'm interested to see the performance of the student. So based on now, let's say I collected data and I got descriptive. So I saw the performance of the student is majority B+, for example. And then why is it happening? Okay, actually B+ is okay, but let's say if they got C, then why is it happening? Okay, maybe they need more time to digest. Then can I predict future? Can I predict future, the performance for the student in the future? Based on my data, the current data, the historic now becomes history. Whatever now you are here, let's say I collected data, you become part of history. But the upcoming student in next semester are the future. So based on your data, can I predict the future performance for the upcoming students based on their characteristic? Probably, if later I know where they are coming from, what courses they attended, prerequisite, and so on and so forth. And then based on my prediction, what should I do? The action is called prescriptive. Okay, so what should I do about it? If I know the performance is going to be very good, so good, majority of students going to get A, then what should I do? What should I do? Only continue? Okay, I continue anyway, but what should I do? Maybe I put more challenging questions to see who can still stay at A level and who can go to B+, for example, or B. Okay, so the point is, prescriptive is about future, what to do based on your prediction. So what you are planning to do. So now you know these keywords when you are using them, what each one represent: descriptive, diagnostic, predictive, and prescriptive. This is same what just now we talked. And the complexity is as you go in higher level. Descriptive is the easy one. The more difficult you go to diagnostic. The more difficult one is predictive. The more difficult one is prescriptive. Okay, so this is what here shows you. The complexity. Here, if you see the complexity versus value. Okay, versus value. As you go from each level of those, the complexity is increasing, as well as the value, the return. Okay, the benefits coming from each one is higher. So prescriptive is higher than descriptive, for example. Predictive is higher than descriptive, and so on. Now, data visualization is also part of data mining in general. Visualize to tell a story. So usually visualization is quite good actually. If you like to become good as data scientist or even data analytics, it's good to know what kind of visualization types you have and which one, each one can tell you what, okay? What types of information can tell you. And it's useful to explore patterns. So rather than looking into the data in raw format, let's say you have Excel file and then you scroll up and down looking into the data in raw format. If you visualize it, then it's much easier to read insights from the data, whether there's positive trend, for example, for your sales, negative trend, seasonality, right? So data is about, visualization is about explore patterns inside the data and to communicate insights. So after that, if you find some patterns inside the data, so what insights that gives you? Okay, you need to decide. Maybe the data has an issue. Then based on this insight, then what you need to do? Maybe fix the problem that exists inside the data, or maybe take an action. You know that there's seasonality coming up, let's say every August. Then maybe let's say the sales are going up usually every year on August. Then what you should do? Maybe prepare yourself in advance. You have enough goods and products, right, for your sales. So a picture eventually is worth 1,000 words, okay, and gives you more abstract view. Okay, so data storytelling is about connecting insights to action. So I would like later, when you are working on visualization, let's say when I give you your assignment, to explore the data and find patterns and tell what the patterns tell you. Not just, oh, like, okay, this is pie chart or this is bar chart. Okay, very nice. You have done that part, but so what? Okay, so try to find what patterns are inside out of your data. Okay, so visualization is about reveal hidden patterns, and then narrative is the storytelling part, which you explain the context and highlight what matters. So out of visualization, so what is the important, what is the insights you gain out of it? And there are different types of visualization. You have pie chart, column, or bar chart. Usually they call it bar chart. You have also for ranking. So if you are doing proportion, you can use pie chart, as you see this one. Maybe here 30%, this is 40%, and so on. So you show proportion, okay? Column also can show you proportion. This is if you use, they call it stacked bar chart. Stacked, where you stack the value on the top of each other, okay? Stacked bar chart. Or you have ranking, like this case. Maybe we're showing, let's say, the top sales for the products. Then product one maybe has this amount of sales. This is product one, product 2, 3, and 4. Okay, so we're showing ranking out of bar chart as well. Over time can be useful by applying line. This is line chart. So this can help you to see the variation in your sales, maybe going up and down. Can be normal or maybe due to seasonality or whether there's a trend inside your data. Like if I look into this chart, if I draw an average bar, maybe it shows me there's a positive trend. Or maybe I draw another one and it shows me my sales are going down. That means I have negative trend. Okay, the amount of sales generally are dropping down. Or maybe I have seasonality. What we mean by seasonality? Like repeated patterns over time. Same patterns is being repeated over time. Okay, so let's say this is January, February, March, April. Let's say every other month you have higher sales. Then the sales drop down, then going up again. Okay, so when you have repeated patterns, we call this is seasonality, especially if we're talking about sales, of course. Okay, also you may use bar chart. Again, they call it column, but also it's called bar chart. So bar chart also may be showing you sales over time. Let's say this is sales for January. This is February, March, April. Okay, so also you can see there's positive trend. There's positive trend. Frequency where you apply what's called frequency. Bar chart, but they call it what? Histogram, right? It's also bar chart. So histogram. Like this one. This is histogram or bar chart. So here we're showing, let's say, I have the age of the students. Maybe this is for 19, 20, 21, 22. And then it shows me here the frequency. How many students I have for each category, for each age group. Okay, I may also use line chart. See, can show me if you have numeric data, of course. Correlation, you can use scatter plot or bar chart. Scatter plot simply means what? Just point. So you have points here. And then it can help me to identify correlation. What we mean by correlation? Yes, correlation. Yeah, a relationship between two variables, right? Can you give me example of correlation? If you look around you, there are many examples in the real world. Example of correlation. Correlation can be positive, negative, and no correlation. Okay, so the relation between the amount of car or number of car exists with number of accidents, right? So as the number of car increases, we may expect the number of incident or accident increases as well. Anything else? Sorry? Height and weight. As the person height becomes higher, he gain more weight, right? Okay, good. Or maybe the number of hours you spend studying reflected on your performance, right? Anything negative? Any example of negative correlation? Negative in your life? The number of hours you spend overnight after midnight has negative impact on the next day activities, right? If you stay overnight 1 hour, maybe still okay. 2 hours become next day, you may expect you're going to wake up sleepy and not able to function properly. 3 hours, 4 hours, right? Or maybe the age of the car and its price. As the age of the car increases, the price drop down, right? So this is negative correlation. No correlation. No correlation, by the way, if you draw scatter plot, the data will look just random. There's no pattern. No pattern inside the data. Any example of no correlation? Your favorite color with your performance. Any connection? No. Your favorite soccer team with your performance. An academic performance. No, right? Okay, good. What is data science? Yeah, so just I'm giving you in this introduction the different concepts. Okay, so what is data science? So data science is about understanding the world through digital data. So you have scientific methods, maybe you have algorithms to apply in order to extract patterns from the data. You have statistics, you have programming, so you can apply programming using, let's say, Python. You have visualization tools, and you have storytelling. You need to implement all of these as a data scientist. But anyway, when you go to industry, always ask for job description. Don't look only for the title. Oh, I'm data scientist. Okay, then you look into the actual job. You're maybe just doing visualization, for example. So when you go to industry, always ask about job description. So if someone calls me and say, hey, we have position for a data scientist. Are you open for new position? Okay, yes. But may I have the job description, please, first? Then yes, okay, we will email you the job description, and then we can further discuss. So always ask for the job description. Don't just stop at the title. Okay. So as data scientist, you need to prepare and clean your data, analyze and build models, visualize and predict, which you are going to do all of this in this course. Okay. So whether you like to call the course data science or data mining, you are going to implement all of these. Okay. And also ask questions like why and explore the root cause phase to uncover real issues or patterns inside your data. So data science is including science, technology, and data. So you have data at your place. You have technology to apply, like machine learning algorithms or data mining. And then you have science, which is the statistics or the algebra or whatever, in order to help you to find insight inside the data. Okay. So the difference between data analytics and data science. For data analytics, usually just they collect data, clean, visualize, and maybe use simple tools like Microsoft Excel in order to look into patterns inside the data. Okay. While data science, you may build predictive model. So you need to apply some algorithm in order to build predictive model, apply machine learning, model training, and deploy your model into the final system. Let's say they have, because building a model is like just you are building an engine for the car. But then later you need to take this engine and deploy it into the body case of the car, right? So deployment means taking this model and implement it in real situation, maybe into a website, Windows application, or mobile application. Okay, so we talk about deployment. And more complex tools. Here they mention Apache Hadoop, for example. Any question so far? So now you know what is data science, data analytics, okay, the different types of analytics that you may apply, and so on. Now we come to artificial intelligence. So actually, now we are going inside our course. So what is artificial intelligence? What is AI? What is AI? Okay, actually, machine learning, yes, is part of artificial intelligence. Okay, good. But if I don't implement machine learning to build a predictive model, can I call such system is AI system, or it must be predictive model? Must be. Any other ideas? Is it must be predictive machine learning there in order to call AI? Actually, AI is more wider than just machine learning. So any system that mimic human behavior in order to answer question for complex task can be considered AI. Let's say you're building a system to play chess, but you're not implementing machine learning. You're implementing some complex algorithms. Okay. Have you studied data structure before? data structure. Okay, so let's say I use some complex data structure like decision tree or binary tree, in order to calculate what next moves for the current chess status. Okay, and then based on this calculation, I decided to go this move next, second move, third move. This has no machine learning. Okay, but I'm using complex data structure in order to mimic human behavior. So I define the rules, maybe each chess stone where it can moves, and then I go and based on the current status for the chessboard, I started to plan what should be next. So actually in artificial intelligence, if wide without using machine learning, you are calculating each and every step. So every time you do a move, you should calculate all the steps and then find maybe the shortest path in order to move, and which move is going to be considered best. Okay, so AI, not necessarily machine learning. Okay, is wider. Machine learning, if you have machine learning, yes, definitely it's AI. But if you don't have machine learning, the system can still be AI system as long as it's mimicking human behavior in order to take an action next. Okay. So artificial intelligence is the science and engineering of making intelligent machine, especially intelligent computer program, by mimicking human behavior. General speaking. Okay, whether there's machine learning or no machine learning, different story. Okay, another matter. Okay, so this is the bigger circle is for artificial intelligence. Then what is machine learning? What is machine learning? If we understand artificial intelligence as a big umbrella for mimicking complex human behavior, right, in order to take an action or to deliver some output, then what is machine learning? Machine learning is about implementing algorithm that help you to inference future value. Okay, not necessarily you are calculating. It's not like if you're not implementing machine learning, you have decision tree or you have binary tree, and then you are calculating each and every move for now. No, actually you may implement some statistics, like let's say regression. Okay, so regression, let me give you a sense what I mean. Let's say I have here the performance of the student, and here the number of hours they study weekly, number of hours weekly. Okay, then I collect the data from the student. So some students have studied maybe, let's say here 5, 10, 15, 20, and so on. And then I collect their performance, let's say 50, 60, 70, and so on. Then for each one, maybe I draw a point. I draw a point, and I notice that generally speaking, what the data shows, there is correlation, right? As the number of hours increases, the performance of the student increases as well. Okay, now based on this one, how I can inference future student, what his performance is going to be like. In order to inference, I need to find what this line is. Firstly, I need to find the best line, because maybe you may tell me, sir, I may have other lines. Maybe how about this line? Yes, can be. How about this line? Also, it's possible. There are many lines can represent the data, but which line is best? Let's say the red one is the best one. So I need to find the parameter for this line, which is the equation you studied in high school, right? Y equal, okay, mx plus c. So what we call m, sorry, the coefficient or the slope, right? If you are using the terms, it's called the slope of the line. And this one, We call it the shift. Yeah, the intercept. Okay, good. I see that I have expert students here. Okay, so these we call them the parameters for a line. Now, if I know these two parameters, the M and C, then can I predict the future? Y here represent the performance. Can. So once I know in the future, so in the future, what I need to substitute? Let's say I found M and C. So how to calculate Y? Just I need to substitute X. So if I ask you how many hours you spend, you told me 40 hours. Wow. Well, I put 40 hours here, Y is going to be 90%, the performance. Okay. So as you notice, actually I'm using statistical model like this one called regression. Okay. In order to inference values for future. Okay. It's not like the chess in AI where I'm anticipating each and every move that can be next based on the current status of the chessboard. Not like this. I'm building statistical model like indirect way. I'm going indirect way. Instead of finding each and every step like the chessboard, no, I'm building indirect way just by representing the data in regression line and then using this regression line to help me to inference value for future, to predict value for future. So actually, machine learning or data mining is all about finding this equation. Once you have this equation, then you can predict. If you don't have this, you cannot predict. And the quality of prediction depends on the value you found for M and C. If you have good values for M and C, then the results is going to be good. If you have bad values for M and C, then your results is going to be bad. Okay, understood? Okay, what is deep learning? And notice machine learning is AI, but not necessarily every AI system is machine learning. And deep learning is machine learning, but not every machine learning is deep learning. Okay, so what is deep learning? What is the difference between machine learning and deep learning? Or the core concept is applying what's called artificial neural network. So the scientists or people, they discovered this way. They inspect human brain, how it works, and they found out we have neurons, and neurons are connected to other neurons. And eventually there's a signal moving from one neurons to another neuron. And eventually we have maybe decision or we have something inside and so on. So they mimic the behavior of the human brain. So they created small unit processes called neuron as well. And then they connected them together and magically, believe it or not, they functions. Yeah, truly. Like now you are using ChatGPT. It's all deep learning. Okay. So deep learning is about mimicking human brain structure and then implementing it in a way. And again, believe it or not, it's working. Okay. Anyway, later we're going to talk more about deep learning. Okay. Now, when we are talking about data, because data mining requires data. If we don't have data, you cannot mine anything, right? Can you mine without data? So your main fuel is there's data, like you are doing gold mining. If there's no gold, there's no point of mining anything, correct? So you need data. Now, when you look into your data, you need to understand how we talk about data. Data can have what's called characteristic or attributes. So what are attributes? Attributes simply are the header or the column name for each column. We have a name. This is, we call it attributes. Okay, we call it attributes. So here, how many attributes I have? I have 1, 2, 3, 4, 5. 5 attributes for house. So I'm interested in characteristic of house. So I have 5 attributes. I have size, location, number of bedrooms, and age of the house, and the price. Now, these also can be called features. Features or attributes. And the features can be divided, or the attributes, into 2 types. Can be input input features can be output. Okay, so what is the output? Why we decided the output is the price? Why output is not age or bedroom or location or size? Can be age is the output? Can bedroom be output? The answer is yes. It depends on your objective, what you are trying to do. So if you tell me I'm trying to build a model to predict the price, the house price, then price is your output, or we call it target. So that the price is your target. If you tell me, no, I'm interested to build a model to predict the house age, then age becomes your target, your output, and the rest becomes your input. All the other attributes becomes your input, and so on and so forth. What we call each row here, in database, we say row or records, right? In data mining, what we call them? Objects. Objects, or we call them data points. What else? I cannot recall for the moment, but mainly objects and data points. Okay, same. Record, if you say I have single record or 10 records, or I have 10 objects or 10 data points, same thing. Now the evolution of AI, how AI has been run into the evolution. So we have rule-based, the three types of system. We have rule-based system, we have machine learning, and we have deep learning. What is rule-based system? Rule-based system, simply, you have data. All of them, you must have data, okay? But in order to come to the rules, you need to hire people. So you need to hire people. These people will sit and start to investigate the data and try to find patterns inside the data. Eventually, we are interested to find what? To find rules. To find rules. Like you're saying 1 + 1 = 2. So you are interested to find these rules, meaning rules like what? Let's say I'm looking to the performance of the student. Then the rules can be like, if the student has studied less than 2 hours every week, and he is participating in community activities, attending club at nights, for example, or just having fun with a friend, he's most likely to fail, unfortunately. So these types of things, we call them rules, okay? And we are interested in these rules. So those people will sit and analyze the data in order to look into, find out the rules, the patterns or the rules inside the data. Once we have them, then they're going to take these rules and implement their system. Oh, then their system looks AI. Wow, smart system. Just based on some input, then the system is able. How? Because they were able to analyze the data. Or another example, spam filter. You are interested to build a system that actually can detect whether the email is a spam or ham. Ham means non-spam, okay? And then what you could do, you said you have 10 emails for spam, 10 emails for ham. Then you inspect spam emails, or people who spam usually, or spammers use maybe words has money value. You won prizes, and they use informal language, right? And they use maybe some phrases like grasp you have 1 hour to collect your prize or you lose. So you find these patterns and then you take them to implement your rule-based system. Then you inspect any email comes to your inbox. If the emails have many of those keywords, let's say by 80% of these words exist inside an email, then you may say this email is spam. Otherwise is ham. So how you come up with these rules? By hiring people, or maybe you set yourself and you find out these rules. Now, machine learning, what does it do? It's supposed to find these rules by itself. The algorithm is supposed to extract and find these rules by itself without having human intervention. Here, human is required, right? Here, human is not required. Then what this person is doing? He's doing different story. He's not looking into rules, but he's trying to make the data looks, how to say, He's trying maybe to come up with new features, new attributes. Like what? Let's say I'm building a system to detect handwritten digits, 0, 1, 2, 3, 4, and so on. Okay? Now we need to find a way. So machine learning is supposed to inspect and tell us what are the rules behind this. So what this person will do, actually this person is not, you can remove it. Still machine learning can work. But this person is supposed to make the data more informative. How? Like we come to this, the data here, what type of data we have here? Images. And images are just pixels. So this is our data, the input data for machine learning. Let's say the machine learning has some confusion to recognize between 0 and 5. So sometimes it tells us 5 is 0 or 0 is 5 and vice versa. So he say what? How about if I add to the data more input, and this input should be more informative. Like what? Like counting the number of cycles inside the handwritten digit. For example, 0 has how many cycles? 1. Circle has 1 circle, while 5 maybe has 2 halves or 1 half. It's up to you how you explain it. So providing this kind of information can help machine learning to become better and better. Like your sibling, let's say you have young sibling, and then he comes to you and tells you, I cannot differentiate between 5 and 6, for example. And you need to simplify it for him. What you tell him? Okay, look, 6 has circle and tail, right? While 5 maybe has only half circle and nail. Okay, so this is what feature extraction. You are doing feature extraction. You are helping your sibling by not only providing the picture of the handwritten digit, but giving him more information. So that can help him to take decision. Oh, yeah, this is 6. Oh, this is 5. Okay, same thing for machine learning. So you're not telling machine learning what are the rules, but you are giving more information. Okay, this is 6. Yeah, this has 1 circle and 1 tail. Oh, okay, then machine learning will remember that this kind of shape is 6 based on your information. Deep learning, as we said, so before I go to deep learning, so in other words, this person is doing what's called feature extraction. He's trying to extract more information out of the data. Like your young sibling comes to you, and then you tell him, okay, and instead of just showing him the picture for 0, 1, 2, 3, 4, 5, you're giving him more information. Look, 0 is just circle and has no tail, no nails. 5 has half circle, 1 nail, right? So you're giving him more information for him in order to differentiate between the different shapes. This is what we call, what you are doing, you are doing feature extraction. You are trying to, out of the existing data, you're trying to extract more information to help him to simplify the case. Deep learning doesn't require feature extraction. This is the powerful of deep learning. And believe it or not, deep learning actually is doing feature extraction by itself. So this is the difference between also machine learning and deep learning. Machine learning requires you to do feature extraction, like you are going to your young sibling and providing more information, simplifying the problem. Deep learning doesn't require that. Actually, it's gonna do the feature extraction by itself. Eventually, what you are going to tell your sibling in a way or another, deep learning is going to find out by itself. Okay. So if we are talking about the differences, or maybe before I go about this, we still have time. Okay, I think just I'll stop here. Next session, I will tell you about the difference when we talk about traditional system, like if you have building FYP system for online, for attendance, student attendance. What would be the difference between these kind of systems and between data mining or machine learning systems? You see, so now we're talking about different perspectives. If you are building online system or if you are building predictive system, what is the difference, the main difference between these two? Okay, Any question so far? Anyone didn't scan attendance?